Welcome to The Explainer. I'm so thrilled you're here because today we're going to completely change the way you look at the ground beneath your feet. It's so easy to just walk past a boulder or stone building and think of rocks as just, well, dead weight. But they're really not. Rocks are these incredible, ancient, historical records just waiting to be read. They've literally witnessed the birth of our planet, roaring fires, shifting oceans, and crushing depths.
Seriously, if a rock could talk, what story do you think it'd tell you? Today, we're going to learn exactly how to speak their language. Consider this explainer your official training guide to becoming a geological detective. By the end of our time together, you won't just see gray lumps on the ground. You're going to see thrilling sagas of fire, water, and immense pressure. Okay, let's dive into this. Here is our agenda for today. First up, every rock has a story. Second, igneous, born from fire. Third, sedimentary, layer by layer. Fourth, metamorphic, changed by pressure. And finally, spotting rocks in real life.
Starting things off with Section 1, every rock has a story.
You know, it's really important to understand that when scientists sort rocks, it isn't some random game based on what looks pretty. It's based entirely on their origin. I actually like to think of every rock type as a comic book hero. Just like Spider-Man has the radioactive spider bite and Superman has the destruction of Krypton, every single rock you pick up has a distinct, dramatic birth story. Where it came from and what happened to it along the way dictates exactly which of the three groups it belongs to.
Moving right along to Section 2, igneous, born from fire.
Let's turn up the heat and dive deep underground into environments hot enough to melt solid rock into a glowing liquid. This brings us to our first major definition. An igneous rock is a rock that forms when hot melted rock cools and hardens, and the name itself is a massive clue. The word igneous actually comes straight from the Latin word for fire, so whenever you hear igneous, I want you to immediately think of blazing heat and fiery origins.
Now, before that melted rock can cool, it has to exist as a liquid, right? And scientists actually use two different words depending on where it's located. When it's trapped deep underground, we call it magma. But when it breaches the Earth's surface, like in an erupting volcano, we call it lava. Let's see how this difference creates the physical rocks we eventually hold in our hands.
Here we have two very different igneous rocks, granite and basalt. The key difference here is all about speed. Granite forms from magma that cools very slowly, deep underground. Because it cools so patiently, the mineral grains actually have time to grow big enough for us to see them. Basalt, on the other hand, forms when lava cools really quickly, right on the Earth's surface. Because it cools so fast, the mineral grains are tiny, like you can barely even see them. So remember this golden rule. Slow cooling equals big grains, fast cooling equals tiny grains.
And this brilliantly illustrates those visual field clues. Because of that slow cooling, granite features these visible, beautiful specks of minerals like quartz, feldspar, and mica. It's speckled and bright. Basalt, born from that fast surface cooling, is usually just a uniform dark gray or completely black. Same fiery origin, but totally different cooling speeds, yielding completely different visual clues.
Let's cool things down a bit with Section 3, sedimentary, layer by layer.
We are leaving those fast, fiery explosions totally behind us. Take a breath and slow down with me to the patient passage of geological time. A sedimentary rock forms when small pieces of rock, sand, mud, or even old shells are pressed and cemented together over time. This is a very watery, patient origin story. We're talking about thousands upon thousands of years of slow, steady accumulation.
Let's just walk through this timeline step by step. Imagine a river carrying tiny bits of sand and mud downstream. Eventually, the river slows down, and step 2 happens. Those bits, which we call sediment, settle to the bottom. Over thousands of years, layer after layer just piles up. Step 3, the immense weight of the top layers presses down on the bottom layers. And finally, step 4, minerals in the water act like a natural glue, cementing all those loose pieces into solid rock.
And this slow process creates some really fascinating rocks. Sandstone is exactly what it sounds like. Grains of sand glued together. It even feels rough, kind of like sandpaper. Then we have limestone, which is incredible because it's often made from the shells and skeletons of ancient sea creatures. Fun fact, if you drip vinegar on limestone, it'll actually fizz. No way, right? Finally, there's shale, which is made from very fine mud and tends to split into these thin, flat layers. But here is absolutely the most wondrous thing about sedimentary rocks. They are the only type of rock that can contain fossils. Think about it. The intense heat of those igneous rocks would completely destroy any remains, but the gentle, layer-by-layer pressing of sedimentary rocks perfectly preserves the traces of ancient living things. If you find a fossil, you are definitively holding a sedimentary rock, for sure.
All right, on to section 4, metamorphic, changed by pressure.
Now, brace yourselves because we're heading back deep underground into an environment of unimaginable crushing forces. A metamorphic rock is a rock that's been completely changed from its original form by intense heat, pressure, or both. Deep underground, rocks are squeezed by the tremendous crushing weight of the earth above them, and they're baked by nearby magma. This heat and pressure literally rearrange the minerals inside the rock to create something entirely new. Now, what's really interesting about this concept is the word metamorphic literally means changed in form. It's exactly like a caterpillar going through metamorphosis to become a butterfly. The rock starts out as one specific thing, undergoes a period of really intense environmental pressure, and then emerges as a completely new type of rock with a totally different look, feel, and structure.
Let's look at some dramatic before and after transformations. Remember our shell-filled sedimentary rock, limestone? Well, when you heat and squeeze limestone, it transforms into marble, smooth, beautifully colored, and favored by sculptors for thousands of years. And remember shale, that layered mud rock? Compress shale hard enough, and it actually becomes slate, which splits into smooth, flat sheets. In fact, people used to use thin pieces of slate as writing boards in school, which is exactly where the word chalkboard comes from.
Just to round out the category, consider quartzite. If you take that rough, gritty sandstone we talked about earlier and subject it to immense heat and pressure, it fuses into quartzite, which is an incredibly hard, tough, and durable metamorphic rock.
Which brings us to section 5, spotting rocks in real life. So we've explored the fiery depths, the ancient rivers, and the crushing underground. Now it's time to put your new geological detective skills to work. Let's lock in this field guide. Igneous forms from melted rock. Your key clue is crystals or a glassy look, like granite or basalt. Sedimentary forms from cemented layers. Your clue is visible layers or fossils, like sandstone or limestone. And metamorphic forms from heat and pressure changing existing rock. Look for wavy bands or a shiny, folded look, like marble or slate. So the crucial point is really just committing these core clues to memory.
You seriously don't need to hike up an active volcano or dive into a canyon to use this knowledge. You can be a rock detective today. The next time you walk past a stone building, look closely. Do you see smooth, swirling colors? You might be looking at metamorphic marble. Do you feel tiny, sandy grains? That could totally be sedimentary sandstone. Do you see specks of different minerals on your kitchen counter? That might be igneous granite. Our cities are quite literally built out of the Earth's history.
Which leaves us with a final question I really want you to think about as we wrap up this explainer today. What ancient rock stories are hiding in plain sight right in your own neighborhood? Next time you step outside, look down. Look at the buildings. The Earth has been writing its autobiography for billions of years, and now you finally know how to read it. Thanks so much for joining me, and happy rock hunting.